we start to look going to the future, which is where I get very excited in terms of where we're going to go to. And we can already see a number of trends that have been developing. Some cynics say, well, you know, as you pointed out, there was a lot of hype of AI 3 or 4 years ago. And hey, we don't have level 5 autonomous cars today. And we don't have artificial general intelligence today. Therefore, AI has failed and we're going into new AI winter. An AI winter, we've had 2 before, one in the 70s and then the other when the Lighthill report and DARPA in the UK criticised the state of AI, and at DARPA, the US Defense Agency, reduced expenditure on AI. And then we had a second one in the mid to late 80s, around 87, 88, when the expert systems market kind of collapsed. And that led to the second AI winter. I subscribe to the view that we're not going into a new AI winter, in spite of what's been happening with COVID, etc., the COVID crisis and tragedy, resulting in a recession or potentially, who knows, even a depression. Hopefully not, but because the following, if anything, COVID has shown that we're very heavily reliant on digital. Companies that had a strong digital presence, such as Amazon, use a lot of AI, have fared much better than, for example, in the UK, we have Primark, which is a fully physical store. And those examples of those who are purely physical and didn't have an online presence are the ones that perhaps are very heavily hit from COVID-19 and the resulting economic crisis. So if anything, digital transformation is going to accelerate, which means in turn, demand for AI and the need for AI or machine learning is going to increase. Equally, when we get into the era of 5G, which is on its way, and we're going to have more connected devices, more Internet of Things, IoT, and that vast amount of data that's going to get generated from connected sensors and connected devices is going to mean that we're going to need more and more machine learning and deep learning on the devices around us to make sense of that data and generate actions in response, often real-time or near real-time, on-the-fly engagement with customers, etc.
And making better decisions, right? Making better decisions based on those recommendations. Yeah.
Correct. So if we take the example of an autonomous car, they may take a bit longer to get to level 5 than some had hoped a few years ago. But maybe as 5G scales and we get more and more advancements, maybe by the end of this decade or 2028 to 2030, I've always felt post-2025 is a more realistic period to look at major advancements in autonomous vehicles, at least towards getting level 3 and 4 vehicles more and more on the road. However, an autonomous car needs to make decisions on the car itself. It can't wait for a signal back from a remote cloud server telling it to stop or turn left or turn right, because A, you might lose that signal, or B, there might be latency, and then in the meantime, it can make the wrong decision and crash or do nothing and someone else hits it. Yeah. Same with robotic surgery and industrial robots, etc. Increasingly, they'll be making more and more decisions on the device itself. So that world of edge computing, which is intelligence on the device, is something we're going into going forwards. And we have had advancements in AI, people overlook that often. We're getting constant incremental improvements, and even in the techniques that are coming through. So for example, we talked about attention and transformers, which came around, I think, about the last 2 years and really started to take off in the last year with GPT-2 and now GPT-3, BERT from Google on neural translation. And also when we go to federated learning, which is a technique that Google introduced, Google also introduced transformers, but federated learning in 2017, but federated learning has really started to take off in the last year to potential wider applications. In fact, we talk about the challenge of data, for instance, and the fact that right now, a lot of the data is being held by the technology majors and the social media giants, which arguably gives them a advantage, some may say unfair advantage, in machine learning and deep learning over some of the legacy companies and startups. And healthcare is a good example. Many AI startups get into healthcare, but then they get the initial funding and perhaps then after 3 or 4 years don't scale in the way they'd hoped to, because the hospitals, for example, healthcare providers are very reluctant to share data because they have concerns about data privacy. Likewise, banks and insurance companies are very protective of their data. And in Europe, for example, there's GDPR with very heavy fines. And the US, there is also equivalent, there are also rules on privacy, etc., that affect the healthcare sector. So federated learning is a means by which we could potentially solve for the data privacy and data security challenge. And an example of how that works, or at a very high level, how that works for the business audience. We start, as we do today, with machine learning on the cloud, train on the cloud, but then we can then place that machine learning onto across distributed servers. Now, this could be, for instance, mobile devices, and it's forecast by some analysts out there, but by 2022, we'll have over 1 billion mobiles, 1.25 billion, I believe, according to Forrester research. 1.25 billion mobile devices will have a GPU, a graphical processing unit, on them. A GPU is like an AI chip, for the sake of simplicity. GPUs have also been very important in the advancement of deep learning, or making deep learning more scalable or accessible. And so more and more mobiles are expected to have these in the next 2 to 3 years. So we may see more and more AI or deep neural networks embedded on the mobile itself. So you could actually do federated learning on the mobile device. You don't remove the data, but you, when the model, if you like, the learning, for want of a simplistic explanation, goes back to the aggregating model. So federated learning is a technique that many in the field hope is going to help solve for data privacy and data security. It's a relatively new area that Google introduced in 2017 and is starting to get some traction over the last year or so. And basically what we do is we start with a general model that's trained on the cloud as it is today, but then you can deploy that onto mobile devices. So for example, it's forecast by Forrester Research that by 2022, 1.25 billion mobile devices will have a GPU on them. A GPU is an AI chip that makes, if you like, deep learning or more accessible. Now, you would then train on the individual data set on that mobile, or as NVIDIA did with King's College Hospital last year, on distributed servers in hospitals. And then that learning that's been done on decentralized data then flows back to that global model. But you never remove the data from the local server, or for instance, the mobile device or the local hospital. What happens is we update the parameters, which is like the mathematics of the model. So the gradients and the weights would get updated in the global model, and then you redeploy it to everyone. So all the mobiles, or in the case of NVIDIA working with King's College Hospital, all the hospital servers. So you get collaborative learning without removing the data. I'm explaining this at a very high level in a simplistic way. There are some criticisms that there are risks of what's called adversarial attacks, that you could still hack into that transmission between the, for example, the mobile device and the cloud server, although there are others who say you could put encryption on that to try and reduce the risk of that. But as these kind of techniques such as federated learning and differentiated privacy that go with it become more and more viable and scale in the future, we should then start to see a real material advancement of machine learning in areas such as healthcare, where data privacy has been kind of the limiting factor or stopping it from scaling. So I'm very hopeful that in 2 to 3 years, areas such as healthcare, banking, and insurance, where data privacy is very, very important in data security, we'll start to see more and more machine learning coming through with areas like federated learning with differentiated privacy.